Good day everyone, I'm Lim Zhou Yi from Multimedia University Malaysia, and I'll be presenting my paper, which is Understanding User Behavior with Web Session Clustering and User Engagement Metrics. I would like to first start with the background of my study. So, what is user engagement? User engagement is defined as the quality of user experience that prioritizes how captivated and attracted a user is towards a website. The term engage here refers to the time, attention, and emotion that are invested by the users in the website. There are three main approaches that are commonly used to measure user engagement, which are self-reported engagement, cognitive engagement, and online behavior metrics. So self-reported engagement uses questionnaires or interviews. Cognitive engagement uses physiological measures such as biosensors and mouse tracking. And finally, online behavior metrics, which is the main focus of this study, are evaluated by using only the weblog. Although online behavioral metrics are not a definite way to explain how users are engaged, it is actually a non-intrusive approach to measure user engagement. To obtain insights into the useful activities of the users, web usage mining can be performed on a weblog. So this diagram shows the process of web usage mining. So there are three main phases in web usage mining, which are pre-processing, pattern discovery, and pattern analysis. In the pre-processing phase, the raw weblog is cleaned to convert the dataset into a more meaningful format. Pattern discovery is the phase to extract user behavioral patterns using different data mining techniques. And then finally, in pattern analysis phase, interesting patterns and information are extracted. In this study, clustering, specifically web session clustering, is used in the pattern discovery phase to extract user behavioral patterns. So the motivation of this study is to investigate how clustering can extract user behavior in web usage mining. And the objective is to provide a systematic method to discover user behaviors in clusters with the utilization of user engagement metrics. So there are two important parts that are presented in this study, which are the performance analysis of different clustering techniques, and second, the utilization of user engagement metrics in describing the user behavior of each cluster. So the clustering techniques are applied on two different weblogs. And after that, the clustering qualities of the techniques are then compared using the cluster validity indices. And two engagement metrics, which are the number of clicks and the number of sessions, are then calculated for each cluster to discover its user behavior. So now I'll present on the methodology of the experiment. So this is a description of both of the datasets that I'll be using, the online roadshow website and the e-commerce website. So the first weblog is obtained from a ready online roadshow website, which consists of 20,135 entries. The log file is collected from July 5, 2021 to August 31, 2021 in a duration of 57 days. And these are the pages that are involved in the website. The second weblog is an e-commerce dataset retrieved from Harvard Dataverse. And the dataset records users' visits from December 1st, 2019 to May 31st, 2020 on the e-commerce website, which covers 183 days. However, for this study, records that are collected in April 2020 will only be used. So the total number of records in April 2020 is around 5 million rows. And the URL recorded in the datasets are further categorized into 23 page categories that are listed here. Next, I'll go on with the process of the clustering experiment. So first is data cleaning. Both websites are first cleaned to remove unnecessary entries and to perform necessary data type conversion. So for the online roadshow weblog, only 3 fields will be used from the weblog, which is user ID, log time, and page. And for e-commerce weblog, also only 3 fields will be used, which are user ID, timestamp, and URI. As the original URI are in the Polish language, So they are then translated to English for easier interpretation in the analysis phase. Another thing is, as there are multiple URI in the website, around 200 plus, these URIs are then manually categorized into 23 page categories based on their relatedness. For example, 2 URIs, the keywords of product inquiry and product details, are grouped into the product page category, as both URIs are related to products. Next, session identification and path completion. So a web session refers to the sum of all of the actions performed by a user from the time of entering the website to the time of exiting it. And the main objective of session identification is to divide each user's actions into individual sessions. So first, the time on each page is first calculated. Next, session identification can be performed with a timeout value of 30 minutes. Next is web session matrix construction. So a large matrix with the size of the number of sessions by the number of page is created. Each cell in the matrix represents whether a specific page has been requested during a specific web session or not. 1 for yes, 0 for no. It's actually a binary matrix. Next is web session clustering experiment. So a total of 4 clustering techniques, which are k-means, k-medoids, bisecting k-means, and fuzzy c-means, are performed on both web session matrices. And 3-dimensionality reduction techniques such as PCA, TSNE, and UMAP are performed on the web session matrices before clustering is performed. But to verify if dimensionality reduction is truly needed to improve the clustering quality, there are multiple experiments set up. So now I'll present the results for the clustering experiment. And first of all is to determine the optimal number of clusters. So I'll be using the elbow graph. SSE here refers to the sum of square errors. So for the online roadshow website, the elbow point is at 10. So 10 is the optimal number of clusters. And for e-commerce website, the elbow point is at 5. So that is the optimal number of clusters. And for this is the clustering experiment. So the notation here, SI refers to silhouette index, DBI refers to DB index, and CHI refers to Kelvinsky-Hesperus index. So a good clustering quality has a high silhouette index, high CH index, and low DB index. So it can be observed in the red square that I have put, the use of UMAP on the e-commerce weblog has drastically improved the clustering quality in terms of its DB index and CH index. However, the use of UMAP on online roadshow does not really improve the clustering quality. This is because UMAP tends to find manifold structures within noises in data, and the larger the data set, the less noise. Hence, UMAP performs better in a bigger data set like the e-commerce data set, but it doesn't really perform well in the online roadshow weblog. And then for the online roadshow weblog, the clustering techniques generally perform better without reducing the dimension of the data set beforehand. This might be because the variables used, which is the number of pages in the online roadshow, are way less than the e-commerce weblog. This means that there is little correlation among the variables in the online roadshow weblog, and reducing its dimension might cause a big loss of important information. On the other hand, reducing the dimensions in the dataset with more variables like the e-commerce weblog is necessary because it removes the irrelevant variables in the dataset. So, after evaluating all of the cluster validity indices for each experiment set up, the highlighted ones in the table is the best performing clustering techniques for that certain data set. So for online roadshow weblog, the clustering result for K middle is the best, and for e-commerce weblog, the clustering result for K middle and UMAP is the best. Now I will present about the user behavior analysis. So this flowchart over here shows the process of determining user engagement of each session cluster. So the two user engagement metrics involved in this process are the number of clicks and the number of sessions. The user engagement metrics are calculated based on time slots and date. So time slots are indicated by hours with 24-hour time format from 12 midnight to 11:59 p.m. And then dates are based on the time period of the data set itself. So the number of clicks and the number of sessions by time slots, and the number of clicks and the number of sessions by dates for each session cluster is calculated. And after the user engagement matrix of each clusters are recorded, min-max normalization is applied to the calculated values. The engagement level of each session cluster is determined by using the quartile formula. The quartile formula is used to categorize the normalized values into 4 equal parts, which are no engagement, low engagement, medium engagement, and high engagement. So this table over here shows, this table on the left shows how the normalized values are categorized into different levels. And the diagram on the right illustrates a snippet of categorizing the engagement levels of the normalized number of clicks and sessions by time slots of cluster 0 of the online roadshow website. So the user engagement level concluded for each number of clicks and sessions by time slots and dates can then be used to determine the overall user engagement level of the session cluster. This can be achieved by summing up the frequency of no, low, medium, and high engagements. The highest frequency of engagement level is assumed to be the overall user engagement of the cluster. So this table shows the user behavior of the session clusters in the online roadshow website and the e-commerce website, respectively. The pages column of the table shows the top 3 most frequent pages and their average proportions in each cluster. So in order to read this table, so we can see based on the online roadshow website table over here on the left. So the user engagement levels by both the time slot and date of cluster 0 itself, cluster 0 and cluster 1 from the e-commerce website weblog, both of them are high. So this indicates that the user of these clusters are very engaged in the web session. Then the users of cluster 0 from the online roadshow are engaged in the web session when they are accessing the redeem history page. Meanwhile, the users of cluster 1 from the e-commerce website are engaged when they are accessing the about page, the order page, and the category page. So by using this calculation of user engagement metrics to determine the engagement level of each session clusters, interested parties of the websites can directly understand user behavior in a more systematic way. So in this paper, a detailed performance analysis of different clustering techniques on 2 datasets is presented, and then 2 user engagement metrics, namely the number of clicks and number of sessions, are used to describe user behavior of session clusters in a more systematic way. However, this work shows that different user engagement metrics can present different engagement level for a session cluster. This is because each of the user engagement metrics represent different focus on the dataset. So the future work in this study involves defining the engagement level for each user engagement metrics in more depth to accurately describe user behavior. That is all for my presentation. Thank you.